So we have the problem. So what is the specific volume of an air vapor mixture at 30 degrees Celsius and a relative humidity of 40% are at 101.3 kPa barometric pressure. So establishing what are the unknowns. So we have here what are the given. So given natin, we have the temperature of the air, which is 30 degrees Celsius. Then the total partial pressure, we have 101.3 kPa. Then this is absolute, and we have the relative humidity, which is 40%. No? So what we're looking for is the specific volume. Okay. So in order to get that one, we need the equation from ideal gas law, which is PVMRT. So where your specific volume, that will be volume divided by the mass. Okay. So deriving our equation, we have volume over the mass, which is mass times this is R times the temperature divided by the pressure, no? So this is now your specific volume that we have. So this is so what we have here is the R of the air. So so this is the partial pressure of dry air and temperature of the dry air divided by the partial pressure of the dry air. And we can we can expand our equation. R of the air, temperature of the air. Then we have from the equation that total partial pressure minus the partial pressure of the vapor. Now, so we have the R. We have the R of the air, temperature of the air. We have total partial pressure. Now what we don't have is the partial pressure of vapor. So we have the equation. Since the relative humidity is given, so we have your RH, which is or your symbol, this one. We have the equation, which is partial pressure of vapor divided by the saturation pressure, then multiply it by 100%. So to get the partial pressure of vapor, so we can derive your equation here. So that will be partial pressure of vapor times the relative humidity, then times the partial pressure saturation pressure of water vapor. So to get the saturation pressure of water vapor, so from the steam table, no? Steam table. Okay, table A-4. So at 30 degrees, so we have the corresponding pressure. So the partial pressure, saturation pressure. So we have 4.2469. So that will be the unit of kPa. Okay. Then substituting it into our equation, so we have relative humidity, which is 40%. So that will be 40 divided by 100, then multiply by 4.2469 kPa. So we have the value. So we have the value of 1.69876 kPa. Okay. So we have the partial pressure of vapor now. Then okay, so let's continue our solution to get the specific volume. So the specific volume we have here our R of the air will be 0.287708. Then multiply by the temperature. Okay. So multiply it by the temperature. 0.28708. So let's put the units. No? So that will be kilojoule, kilogram, degree Kelvin. Then it will be multiplied by the temperature of the air, which is 30 degrees. So 30 degrees Celsius plus 273. That will be make it Kelvin. No? Then divided by. So we're going to divide by the partial pressure of the change in partial pressure. So we have 101.3 kPa, then minus Bay4 we have that is 1.69876 kPa also. Okay, so we have now the specific volume. So we have the value of specific volume, which is 0.8733. So that will be cubic meter per kilogram dry air. Okay, so this is units, so it will be kPa, cancel out natin, that will be kilonewton, no? Kilonewton per square meter. So this will be kilonewton meter. So cancel na yan. So we have meter, Kelvin will be cancelled out. Then so we have the answer now. So same units, no? Just checking the units. Okay. So bringing down the psychrometric chart, no? So we have the given value, which is 30 degrees Celsius. So we have put it in here, 30 degrees Celsius, using the psychrometric chart. So 30 somewhere here, huh? So I'm putting it here, 30 degrees. So it will be, let's check, huh? 30 degrees, then masyado na mababa ito. Then we have that is how many percent RH? 40% RH. So let's see. So 20, 30, 40. So it's here. Okay. Yun. Somewhere here, but that is already 12 point specific volume dry air. Dito masyado din natin makita, that is 12.5, 13, then so on. So if we're using the wet bulb, so since let's see, it is a wet bulb, since sa calculation natin malay and that is cubic feet of dry air, cubic. So we're using a different psychrometric here. Wait, we'll see. We'll be using another psychrometric chart, no? I'm using this one. So we have 30 degrees dry bulb, since yung isa is different, but it still can be used, but napakalayo na. So we use the 30 degrees, okay, temperature, 30 degrees, so dito yan. Then going up, we go to how much? That will be 40%. So ito yan. So we have 0.80, that will be specific volume kilogram. So that is 90. Okay, cubic meter. So we have 88. Then we have 84 cubic meter per kilogram. So 90, okay, that will be 0.8. So that is in between, no? That is 88, and we have 86 and 87. So by using the psychrometric chart. So madali rin siya makita. So we have here the value for that will 0.87 na. So that will be cubic meter per kilogram. Okay, so that is by using the psychrometric chart. So we have here 40% RH. So ito yung curve na ito. Then we have your dry bulb temperature, which is 30 degrees Celsius. Okay. So next problem, we have a mixture of dry air and water vapor is at a temperature of 21 degrees Celsius. And it is under a barometric pressure of 101.3 kPa. Then we have the dew point temperature, which is 15 degrees Celsius. So find A, the partial pressure of water vapor, B, the relative humidity, and C, the humidity ratio, and D, the enthalpy, and E, the specific volume and the degree of saturation. So first things first, again, so let's establish what are the unknown given to the problem. So we have your given. Okay. So we have the 21 degrees. So we have your dry bulb, 21 degrees Celsius under the barometric pressure, which is your total partial pressure, which is 101.3 kPa absolute. Then we have the dew point dP, which is 15 degrees Celsius. Okay. So let's look first yung A, which is the what will be the partial pressure of water vapor. So partial pressure of water vapor can be determined by using the steam table. So from steam table, so let's use from steam table. At about the dry bulb temperature, which is 21 degrees Celsius. Okay. So we have so we have at 15 degrees, from that is 21 degrees. So dry bulb, dew point. Wait. So this is 15 degrees. Let's go to 15 degrees first. So this is 15 degrees Celsius. So 15 degrees we have here. Okay. So at 15 degrees, the saturation pressure, that will be 1.7057. So that will be kPa absolute. Okay. So next question, partial pressure of water vapor. Okay, 21 degrees under barometric dew point temperature will be 15 degrees. Okay, for letter V, so the relative humidity, so what we have here, the relative humidity. So looking back to the steam table, no? So from here 21 to 25 we need to interpolate again using this value. Okay. So from here, so relative humidity, so that will be the saturation pressure. So what we need is the saturation saturation pressure. We need to determine the saturation pressure of water vapor at 21 degrees Celsius, since that is given to the problem. So what we have here, we have 15. I'm going to interpolate 15. Oh, sorry, that is wrong. So then we will be starting 20, 21, and 25. So we have the value of how much this one is 2.3392. We have your x. Then we have 3.1698. Okay, so we need to interpolate this one. So we have 20 minus 21. Then we have 20 minus 25 is equal to 2.3392 minus the x divided by 2.3392 minus 3.1698. Okay. So getting our calculator, we have the value. So we have here 0.2 is equal to 2.3392 minus the x divided by, so we have negative 0.8306. So cross multiplication, we have 0.2 times negative 0.8306 is equal to 2.3392 minus the x. Then finally we have the value of x value. So we have the value of 2.51. So that will be in terms of kPa now. So we can use that one value for the saturation pressure. So this will become our PD, no? Saturation pressure of water vapor saturation pressure vapor at 21 degrees. So solving for the relative humidity, okay, so we know that our relative humidity is equal to the ratio of partial pressure of vapor then the saturation pressure of vapor, then multiply by 100%. So what we're looking for is the relative humidity. So substituting RH, that will be equal to kanina we have 1.7057, so it will be 1.7057 kPa absolute divided by 2.51 kPa absolute also. So we have now, so we have the value of 68% multiplied by, so we need to multiply by 100. So we have the relative humidity of 68%. Okay. So let's go to the C, solving for the value of humidity ratio, okay, which is yung W. So we have your equation, so that is equal to 0.622 times the partial pressure of vapor divided by total partial pressure minus the partial pressure of vapor. So substituting, we have 0.622, that will be partial pressure of vapor. So your vapor will be So that is 1.7057, then divided by total partial pressure, which is 101.3 minus 1.7057. Okay. So this is in terms of kPa, also the units. So establishing the units, is better to check our calculation is correct. That will be mostly dapat magka-cancel out ang common, which is yung, so we have the value of 0.01065. Okay, so this is in the ratio of kilogram per kilogram of dry air. Then let's go to D. No, so D is solving for the value of enthalpy. For the value of enthalpy. Enthalpy using the IHBE formula. Okay, so we can use your H, which is equal to 1.007 times the temperature minus 0.026 plus the humidity ratio times 2501 plus 1.84 T. Okay, so substituting the values. Okay, so we have now your enthalpy 1.007, then we have the temperature, which is 21 degrees Celsius, no, minus 0.026, then plus in W. So nakita na nakuha na natin yon, that will be 0.01065, then multiply by 2501 plus 1.84. So bracket na natin to, then multiply by the temperature. So temperature is 21 degrees Celsius. Okay, then finally we have the value of your enthalpy. So we have this one, this is 21.147 minus 0.026, then plus, okay, dun sa loob. So we have here 27.047. So finally we have your enthalpy. Then finally we have the enthalpy of 48.168. Okay, so that will be kilojoule per kilogram dry air. Okay, so let's go for letter E. Solving for the value of specific volume. Specific volume. Okay, so again we have your from your PBMRT, no. Okay, so we can derive your mass, volume over mass. We have your RT over the pressure. So substituting the value R of the air, that will be 0.28708. So this will be kilojoule per kilogram Kelvin. Then multiply by the temperature, which is 21 plus 273, will be in Kelvin. Then divided by the pressure, which is we call it the pressure of the dry air. So this is the dry air. So we have 101.3 minus 1.051, which is the partial pressure of vapor. So this is kilonewton per square meter. Okay, so this is kilonewton meter. So cancel out. You have your Kelvin, cancel out. So we have the specific volume now is equal to so we have the value of specific volume, which is 0.8474. So this is cubic meter per kilogram, no? Okay. Now cubic meter per kilogram, then we have your dry air. Then solving for the value of percent, solving for value value of percent of saturation. Okay, so we have your equation U, percent saturation, that will be the RH multiplied by total partial pressure minus the saturation pressure. Then we have your total partial pressure minus the partial pressure of vapor. Okay, so your RH natin kanina, going back, so what our RH will be 68%, no? So that will be 68, then multiply it by the total partial pressure, which is 101.3. Then our saturation pressure, PD, going back, saturation pressure, relative humidity, so that will be 251, no? Okay, 251. So we have 251, 2.51, 251. Okay ba? Okay. Then divided by, so this is KPA, absolute. Then divided by 101.3 minus the partial pressure of vapor, what will be, that is 1.757. So this will be 1.7057 kPa absolute. Okay, so we have now your value. So we have the saturation, which is 67, okay, 67.45, value of percent of saturation, 67.45%. So let's try to use the psychrometric chart. Okay, so what we're given there, we have a dry bulb temperature, which is 21 degrees Celsius. So 20, 21, so it is somewhere. So let's try to zoom on this one. So 21 degrees Celsius. So we have 25, we have 21 here. So let's put it here. This is 21 degrees Celsius, which is your dry bulb, no? Then data natin, other data is what we have is 15 degrees Celsius, that is dew point. Okay, so let's try to plot it one dew point. So that is dew 21 degrees, 15 degrees, the dew point siya at 15 degrees. Let's plot that one. So dew point niya 21 degrees. So from here, okay, so let's draw the line here. So this is now yung dry bulb temperature natin. Okay, so upon reaching at 15 degrees Celsius, call this at 15 degrees Celsius, it will dew. So we have dew point temperature. So that is in 15 degrees. So plotting it here. So somewhere here. Okay. So the dew point temperature 15 degrees. Okay. Here. Then okay, let's draw again a line here, passing here. Okay. So from here, straightening the line. So let's draw a straight line here, passing here. So what we have here now is this one. So that is the humidity. So we have the humidity, which is the ratio, that is the units of grams of moisture. So this is, maybe we can assume this is 10, no? So that is almost halfway. So it can be 0.1. So it can be 0.1. Okay, then we can assume 0.106, since it is in between of this one, that is 10. Okay, then this is will be 11, 12, 13, 14, 15. Okay, so the units of kilogram per kilogram of dry air. Okay, hindi lang siya masyadong accurate when you do calculation, but by using the psychometric chart we can determine it also. So dito tayo nag-intercept sila. So we have interception here, no? So determining also the relative humidity, you will notice here this is so we have 60% and 70%. Okay, so it is in between here. So it is can be identified as a 68%, no? 68% relative humidity. Now for the enthalpy, okay, so we can draw a line here going here. So parallel doon sa line ng enthalpy. Okay, so we have the value of enthalpy. So that is, this is already 50, so we can assume this is 45, 46, 47, 48. So we have value of 48 in here. So it can be 48 kilojoule per kilogram dry air. Okay, so that is one of the advantages of using the psychrometric chart, no? Madali lang. Then for the specific volume, yung V, so that is the slant height line here. So we can, so this is 84 in between of 86, no? So it is somewhere here. So it can be as 84. What we have here can be also 0.80, 84 din siya, no? 84.7 we can get that, but also, or 84.5, since it is in between of 0.84 and 0.86. Okay, then the saturation, percent saturation, so I don't know if we have that one in here. Saturation pressure. Okay, percent saturation, if the curve, okay, I don't think so. Not shown here. Now for the wet bulb, you can also get the wet bulb here, since this is the temperature. Okay, wet bulb running from here. So that one corresponding in wet bulb, so it's between 15 or 15, 16, 17, 18, 19, 20. So that is between 15, 16, 17, in between 18 and 18 and 15, 16, 17, 18. So it is between 17 and 18 yung wet bulb temperature. Now for the saturation pressure, since we have here given here, we have vapor pressure mm of Hg. So corresponds siya sa kabila. We have the units, so that's not dew point temperature degrees Celsius. So we have vapor pressure sa kabila. So we have here running line going here. So that is 12. Maybe that is let's use maybe around 12.9 mm of Hg, no? Mm of Hg. So let's convert that one to. So we have the conversion of 1 mm of Hg is 113, no? So 1 mm of Hg is equal to 113.33. So the units will be Pascal. Okay, so this is PA. Okay. So we have now value. So we have 1719, okay, 0.57. So it is 1.719. So this is already GPA. Okay. So saturation pressure saturation pressure of vapor at dew point temperature, we have 1.70, okay, 57, okay, so it's almost close. For the saturation pressure of vapor at 21 degrees Celsius, so let's try to find that one also. So at 21 degrees Celsius we have 21 in here, going here, passing here, okay, somewhere here. So drawing the line again, okay, so drawing the straight line. So we have somewhere so that is 18 point something, so 18.5 maybe, so m of Hg. Then we convert it by multiplying 1.3 Pascal. Okay, so let's try if it is the same or not. Okay. So using your calculator, so we have the value of 2466. Okay, so that is almost close then, no? So I'm going to transform this is also a KPA value. Okay, so you will see that how convenient it is using the psychrometric chart, no? So very convenient siya. We're using the psychrometric chart to determine the values of the comparing. So if we're trying to get the exact value, we can use the calculation. Then if we want estimating value, we can use the psychrometric chart, which is very easy to plot the curve, the lines and the curve to determine the values.